Question 5 refers to basically how to work with exponents in combination with surds, because you see somewhere you will observe square root, you have observed cube root of expression which is squared, okay, and so on. How to work so that the final polynomial should be represented in exponential form for each term. So each term of the polynomial should have an exponent form, so x to some power. How to do that? You just need to convert all square roots, all roots of different powers into the exponents, all right? And just remember how we work with indices. So this basically referred to their topic, which is called indices or index form, how to work with that. All right, so what am we gonna do? I'm just gonna continue here. First of all, I'll convert each roots in the powers. So x squared, so that means we have minus x. The power stays in the top while the bottom takes the power of the root, okay? So the power of the root, in this case 3, goes always in the bottom part, okay? That's how we convert into the exponents. So x, however, the power is not really stated here. Square root means a root of power 2, so that means we have in the power 1 over 2. And we add x to the power 1 over 4. Okay, so what we're going to do right now, we just need to expand the brackets. So I'll take the first term, for example, x squared, and multiply by the first and by the second one, okay? So this is how it works. During multiplication, you add in the powers. So 2 plus 1 over 2 is going to be 2.5, okay? 2.5. Next one, x squared times x1 over 4, it's going to be plus x to the power 2.25, okay? Then you go next, and you distributed negative x to the power 2 over 3 by each term. So you multiply by each term. So that's why it's going to be 2 over 3 and plus 1 over 2, okay? You'll get, right now I'm just writing 2 over 3 plus 1 over 2. And the last term, which is minus x to the power 2 over 3 and plus 1 over 4, okay? You're just adding indices, all right, all powers. So I'll continue here, and let's see what we got. I just want, so you can leave as it is because you're not really stated what exponential power should look like, but just if you want, I can show you how to convert into improper fractions. So 2 times 2 is 4, plus 1 is going to be 5. So as improper fraction, we've got 5 over 2. So next one, the same, is going to be 8, and plus 1 is going to be 9. So 9 over 4. And here we need to add the powers. So how to add two fractions? Let's remember how it works. You just go to the common denominator and use the crisscross. So 3. Okay, it's too small. Okay, 3 goes here and 2 goes in crisscross way here. Okay, it's going to be 4 plus 3. You get 4 plus 3, you get 7 over 6. Okay, that's going to be solution. I mean, not solution, but interim operation. So it's going to be 7 over 6. Okay, and the last power is 2 over 3 and 1 over 4. You do the same. So you multiply in denominators and goes in cross way as the common factors, okay? So it's going to be 8 plus 3 is going to be 11. So finally it's going to be 11 over 12. So this is the way how it works. So I subtract 11 over 12. And let's have a look. Everything meets the requirements. So each term is written in the exponential form. If you need finally to convert back, for example, into the surd form, there is no problem. For example, I'll just show you how to do that. So this is solution right now. And I just, for simplicity, if you have another assignment, for example, you need to perform every single term in the third form. So how to convert back, basically using the roots. The bottom part tells you the power of the root, so it's going to be square root of x to the power of 5. But you know that this expression can be even more simplified because you can represent as x to the power 4 times x. So you can simplify and you'll get x squared, square root of x. Okay, so if you want, you can perform this form or give this form, or you can stay with the original form. Okay, so and you can convert term by term in the same way. Okay, so hope you got it. That was everything referred to indices and everything referred to, you know, how to work with exponents, how to maybe approach quadratic equations just a little bit, but basically they were about surds again. And here is the final question about simplifying, rationalizing denominator. Okay, let's have a look.